Welcome to our tutorial of ProfLearn YouTube channel. In this particular video, I want us to have a discussion on Unit 3 Physics of Edexcel ASC Physics. We get to see which are the concepts you really need to understand how to work out as you are preparing for Unit 3, which is Practical Physics 1. This is a paper that you need to prepare, and it's going to test the practical skills that you've been doing in Unit 1 and Unit 2, that is mechanics and also electricity and waves. Now, for instance, here we are provided with a spring, and what you realize is that we have a force meter, we have a rubber band. The student investigated the force needed to break this. So basically this is a stretching of materials, which we learned when we were discussing about Hooke's law and how a rubber band stretch. Then we are supposed, one of the concepts that you need to understand is how to identify safety measures when you are performing experiments. And that is going to really be based on the practical you are given, the scenario and the context you are given in a given question. So in this case, we have a rubber band. So one of the things that can happen is that the rubber band can snap. In the process, it can go straight and hit somebody's eye. So one of the protective measures we can take here is ensuring we put on protective goggles so that in the event this rubber band snaps, the person who's doing the experiment is protected. And also something else we need to notice is that if you are pulling this force meter down, it means that there's likelihood of this particular stand toppling. So we can be able to use a G-clamp so that we can be able to fix this particular section here so that it does not topple or it does not overturn, right? Or you can even decide and bring a heavy mass on top of this so that you can be able to maintain it and keep it intact in that case. Yeah, so those are some of the precautions that you need to identify. So based on the experiment that is given, you need to know how you are supposed to approach question to do with safety precautions. I need also to mention another area here that you are like it. Describe the method the student could use not include a force meter. What else could have been done in order to determine the breaking force of this particular rubber band? What we can say, the force meter can be removed, and then once that's done, we add different masses on the rubber band. Keep on adding the masses gradually on the rubber band, and remember, when you add the mass, it will keep on stretching until you reach a point where you get a given mass that will make this to break. Once you have gotten that mass that makes to break, then you can now calculate the force that breaks this rubber band using the formula mass times gravity. So that is what you're supposed to do in that case. Explain why it's appropriate to repeat measurements. Remember, measurements are repeated so that we can have values we can be able to find average. And in that way, if you repeat measurement, you can be able to reduce the effect of the random error that can be caused by some of the changes in this particular experiment. Repeating measurement and values reduces the effect of random error by the variation of temperature in that case. The second experiment that was given to candidates is whereby a ball was dropped from some height, then it could bounce on the slope, and then they could be able to measure the distance x. So we are supposed to state control variables that could be taken here, because what is being changed is the angle of orientation or the angle of inclination, and then the distance the ball covers in the horizontal direction is measured. So what should be controlled? We can control the type of ball you are using, because if you use a different ball, it may bounce at a higher rate. But so to ensure that we don't affect these values, we have to ensure that the type of ball used is the same. Also, we can talk of the point from where the ball is being dropped. That position should be maintained so that the gravitational potential energy, the GPE, is maintained. Because if you raise it higher, it means the ball will have a higher gravitational potential energy. Then it will reach here at a higher speed, so it will bounce more. So, and that will affect this experiment. So the position from where the ball is released should be kept constant throughout. The height from where the ball is dropped should be kept constant, and because the height can affect the gravitational potential energy of the ball, so the impact velocity may vary, and that could affect the distance in the horizontal direction. One of the challenges that students said whenever they are performing such an experiment is that sometimes could be able to have a challenge to judge where the ball finally fall. You see, like for instance here. So the best way to do that maybe is to have a tray of sand, so that by the time the ball bounces and falls, it can stick in the sand, or if it bounces again, it can leave the dent, so that you can be able to see where the ball had fallen. So that's a measure that can be taken. So another concept that could be tested is the use of criticizing the data that is recorded. So when you are criticizing the data, what are the aspects you are checking? You check whether there is consistency in the number of decimal places. You check whether there is evidence for repeating the data collected, so that you can be able to identify the errors and anomalous errors there. And also check if there is a trend in the values that we have. But when you look at this question, there is no consistency in the number of 1dp. Here there's no number of decimal places. Here is one decimal place, is one decimal place. So there's no consistency in the data recorded in terms of the number of decimal places. You can also criticize by looking at there's no evidence for repeats here. Yeah. And if the data was for plotting a graph, how can somebody do 3 values and they want to draw a graph? Then this means this the data is not enough for a reliable graph, right? Yeah, so whenever you are criticizing, base your answer in the number of decimal places, evidence of repeat, and also the recording of at 20.5 degrees, you see it's 592. Something's wrong there. So you look at also the consistency and the trend that is followed. Explain one modification to reduce the error. That's what the one I mentioned regarding placing sand, or we can even use a camera to record the slow motion, so that you can be able to see where the ball landed. Yeah, so basically that's what you're gonna look at whenever you are answering a question on that. We have question 3, whereby we are told that a student determines the speed of ultrasound, and then you are supposed to describe the method to determine a single S accurately using a meter rule. How do you use a meter rule to make an accurate measurement? This is a question that's going to repeat in many papers, and I'm going to show you different papers where the same question is asked. The first thing, we have to ensure that the meter rule is clamped in position and is brought close to where you want to take the measurement. You clamp the meter rule in position, and then ensure that the meter rule is vertical. And how do you ensure it's vertical? you look at the set square. You use a set square to check whether the meter rule is vertical. In that case, you can see I've placed my set square here to check whether this is vertical. And when you're going to read the reading, you are going to ensure that you are reading perpendicularly so that you avoid the error of parallax. So whenever you're using a meter rule, for safety and for accuracy, you have to read properly to avoid error of parallax. And the zero mark of the meter rule should be coinciding to the lower part of the transducer so that you can be able to take the measurement. So these are the steps you need to follow. Clamp the meter rule, use a set square to ensure that the meter rule is vertical, align the zero mark, and then position your eye perpendicularly to measure the measurement. Ultrasonic transducers meter the pulse. So we were supposed to show that the speed is 330. This is determining the speed of sound. So we are told in 1 division is equivalent to 0.5 millisecond. So the time scale was set as 0.5 millisecond per division. So for us to know the time taken for this pulse to travel and to be detected, we shall count the number of divisions, and the number of divisions basically here was 6. So 6 times 0.5, we are going to get 3 milliseconds, and you have to convert millisecond to seconds by multiplying by 10 raised power negative 3. So meaning that we have our time. But remember, when we are talking about pulse being transmitted and being detected, so the pulse will be transmitted, it will reach the surface of water, then it will come back. So it will cover twice the distance. Then for us to work out speed, we are going to say what? We are going to say that speed is twice the distance. Speed is going to be twice the distance over the time taken in this case. And if you work it out, you are going to get your answer as 331.3. which is approximately 330 as it was given at that given point. So once we are done with that, another question that you really need to prepare on is calculation of uncertainty. Calculations of uncertainty, in this case, there is a situation whereby you'll have a single value and they will give you another question where you have multiple set of values. So in this case, when they have given you multiple set of values, it means you have to find the mean of this set of values, and then also you find the range of the values. So the first question you can see they have asked here is to find the mean, and the mean is the sum of all the values divided by the number of data that you're having, which is going to be 4. So if there is no anomalous point, remember sometimes you'll find a value that is very strange, you'll eliminate it or you'll assume it, you'll ignore it. But in this case, there's no anomalous point. We'll add all the 4 speeds and then divide by 4, and that translates what? That translates to 341. Then for you to determine the percentage uncertainty, when you are given data values, different number of values, you need to find the range. Then for you to find uncertainty, it will be a half the range. For this case, our range is 12. The largest value minus the smallest value was 12. Then a half of 12 is giving us 6, and that's going to give us our uncertainty. Then percentage uncertainty will be the 6, which is uncertainty, over the mean that you had gotten here times 100, and you're gonna get your answer being equivalent to 1.8%. I told one of my candidates should sign against here. The student must sign here. Why? You must always, anytime you're working out percentage uncertainty, you must give your answer to one significant figure or two significant figures. That's a rule. That's why I told that student to sign. Also, you should sign wherever you are, sign, so that we confirm that I told you, so that whenever you will make a mistake of writing 1.76, you don't have to come to blame me. So when you write 1.8 as your final answer, the examiner will be happy. Okay, all right, so let's move to the next bit. We are told the student modified the apparatus to determine the speed of sound in water. you determine the speed of sound to be 1444 meters per second with an uncertainty of 4%, right? The accepted value, you are told the accepted value of speed is this value that is here, but the calculated value is this. So we are supposed to deduce whether the student's value for the speed of sound was consistent to the accepted value. So in such kind of a case, in that such kind of a scenario, what you need to do, because the calculated value is actually less than the accepted value, so what you are supposed to do, what you are likely or you are advised to do, or what you are supposed to do, is to work out the upper limit of the calculated value and check is the accepted value within the upper limit of the calculated value. If the accepted value is within the upper limit of the calculated value, then we can say it's consistent. And then now we can check. If you work it out, you are going to get your answer as 1502. So you can see you were given 4%, so I said 1 plus 4 over 100, so that I get the answer direct. Otherwise, you are supposed to work out 1444 times 4 over 100, you get plus or minus what. So this gave me direct, and this is consistent because the accepted speed is within the upper limit of the calculated speed, right? Yeah, so the next bit is a scenario whereby you are given a single data. In the question where we have just worked out uncertainty, we were given a number of values, then you were supposed to work out the mean, then find the range, use the range to find the uncertainty, because uncertainties have the range. But when you are given a single data like this, the approach is different, and these two questions must be in a paper where you are given about 3 data. You are supposed to work out percentage uncertainty, and another question will be there in this paper. In any physics unit 3 paper, you will have 2 scenarios you are finding percentage uncertainty, and we have talked about the other one. Now let's look at this. Here the least unit, least measurement that can be taken by this instrument is 0.01. That's the least unit because it's in 2 decimal places. So the least unit is 0.01 millimeter, and this is also known as what? It's also known as resolution. Are we together? So it means now uncertainty is equals to a half of times the least unit. This is what you are going to do, or a half of the resolution, and this is going to be 0.005. Then now percentage uncertainty will be 0.005 divided by the value you were given, which is 0.27 times 100. Then if you work it out, you are going to get your answer equivalent to 1.9. Remember, I told you to sign anytime you are working out percentage uncertainty, give your answer to one significant or 2 significant figures, nothing more than that. The student repeated the measurement of D at a different position and orientation. Explain another technique she could use to determine the accurate value of D. Check and correct the zero error by either subtracting or adding the error to reduce the systematic error. Don't say to eliminate, don't say to remove, we say to reduce the systematic error. So anytime you are given a question like this, another technique is about correcting the zero error in the measuring instrument. We have part B. We are supposed to explain why the fixed resistor is included in the circuit. In this case, is to limit the maximum amount of current that is flowing through the circuit, so that we can be able to prevent overheating in the system. Another type of question that you really need to prepare on is how to find quantities from graph and also drawing graphs. Now, in this case, we are saying using the circuit in B, the student investigated how the resistance between R, the resistance R between the point X and Y varies with length. And the relationship that was given here is R over L is equals to negative KL plus rho over A, where K is what? A constant. This is the symbol for resistivity. We have A as the cross-section area. Explain how the graph can be used to determine the value of resistivity. Now, remember the graph that was plotted is a graph of R over L against L. So meaning on the y-axis, we have R over L, x-axis, we have L. So which means, and since this is a negative sign, the graph will be sloping on to the left like that. I'm just trying to figure out the data that is given. But if you compare this graph that we have here and the graph of a straight line y equals mx plus c, we can identify that this section here, negative k, is corresponding to the gradient. So negative k is the gradient of that graph. And then resistivity of a cross-section area correspond to the y-intercept. Yeah, we are just trying to relate, comparing this given equation with the equation of a straight line. So we can say, comparing this, we can see that the y-intercept is this section here. Yeah, so since they are asking us how you can be able to use the graph, you are going to read the y-intercept. You read that y-intercept and you say is equals to P over A. And then, which means that now, not P, rather, is rho, right? Okay, yeah, that's an international crisis, rho over A. So we can now therefore say rho is equals to A times the intercept, because now if you multiply A both sides, you're going to remain with rho. And then we can say rho can be calculated from the cross-section area times the intercept. Now, you are also going to fill in data on a table. Something that you need to realize, these are in 3 significant figures, 3 significant figures, 3 significant figures. You are calculating R over L also must be given in 3 significant figures. Be consistent in the number of significant figures. You check on this section that you have here, and then you record that to 3 SF. And also the units. The unit must be indicated on the area you have calculated. Most of the time, there is a mark attached to that. And how do we get that? We said, because resistance over length, it is going to be ohm over meter. So that becomes ohm meter negative 1. And that is the unit that we have at that given point. Plotting, you plot the graph and use the graph to find the gradient is another concept that you need to know. And don't forget to write the correct units of the gradient. And the graph that we were supposed to draw here is this graph. And you can see our beautiful y-intercept is well elaborated here. I've indicated finding the gradient using a section of the graph, and make sure you use a big section of the graph equivalent to a bit longer, right? A bit longer in that, more than a half the line of the graph. Determine the value of rho. Of course, we had mentioned in the previous section that that is going to be what? That's going to be cross-section area times the y-intercept, and the y-intercept already we have seen is 21 from this part. You can see the y-intercept here is 21, so I can be able to use it down there. But we are also required to work out the cross-section area, yet we are given the diameter, so you have to convert this to meters. And then find the cross-section area to be 5.73 times 10 to the power negative 8 meter square. Work it out, you are going to get your answer 1.2 times 10 to the power negative 6 ohm meter. Ohm meter, like that. Yeah, so if you have gotten value from this particular tutorial, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. See you in the next video.